This was 6-5, right? 6-5, we basically talked about two major things, was plotting the complex number and then finding its absolute value, and then converting from complex number into trig form. So for -3, +5i, if I were to plot it, okay, that'd be -3, so back 3, and then up 5, 1, 2, 3, 4, 5, something like that. Make sure it's a dot and not a line. This is a point, okay? And then to find the absolute value, we're doing the square root of a squared plus b squared, just like we do for magnitude, radius, all that good stuff. So if I do that, then the square root of -3 squared plus 5, we don't take the I, we leave the I off, and I get 9 plus 25, which is the square root of 34. So it would be the distance from 0, 0 to that point, okay? That would be the same measurement. But when we graph, we're just graphing the point itself. Good so far? Yeah. 2 is 0 and then 5i. That's what's missing there would be a 0. -5i. So this time you'd be going left, not going left or right at all, and going down 1, 2, 3, 4, 5. That would be your plotted point. And then square root of 0 squared plus -5 squared, 0 plus 25, and the square root of 25, which is 5, which makes sense. Again, this would be the distance from here to here. So the magnitude or the distance from 0 to the point is 5. Yep.
Will you ever get a question where it's 5i plus 5?
Sure. Yeah, good question. Could it ever be reversed? Absolutely. The A is always the one without the I. The B is always the one with the I.
And the I will always be the y-axis, right?
Correct. So if this was switch, if it was 5i minus 3, it'd still be the same point. Yeah. All right, then it said to write the complex number in trig form. So from here, the first thing we can find is that r is the square root of a squared plus b squared. And then we can say that the tangent of theta equals b over a. Find the inverse of that tangent based on that value and where it's located on my circle, in which quadrant. And then my overall answer is going to be in, so r would equal z would equal, switch that around. Z would equal r times the cosine of theta plus I, and don't forget the I, because a lot of people do, times the sine of theta. So if I look at 3, we already know where it's located based on the picture. We already drew this one, okay? But if you didn't, I would have tried to draw it so that I know which one to pick, okay? I also know that the magnitude is 5. So the radius is the same thing as the absolute value. Those are all the same thing. That's 5. And then the tangent of theta would be b over a. So this is -5 over 0, which is undefined. And remember, we talked about there's going to be like a fixed number of options here, right? Tangent based on my unit circle is either going to be 0, √3, 1, √3 over 3, or undefined. So as long as you've memorized those 5 and where they're located, which angle they match with, then all you got to do is then apply the quadrant to it. So we know tangent's undefined at 2 places. What are the 2 places?
Pi over 2 and 3 pi over 2.
Good. Pi over 2 and 3 pi over 2. So based on our initial graph, we would say that this is which of those? 3 pi over 2. So tangent is 3 pi over 2. And then I just plug it in. So 5 times the cosine of 3 pi over 2 plus I times the sine of 3 pi over 2.
Do we have to do like the z equals?
No.
Okay.
No. I don't need it. If you have it, you have it. If you don't, it's not a big deal. Okay, so then 4 is 1, and this would be 1. So I'd be going to the right 1, and I'd be going up 1, which puts it in the first quadrant. My r would be the square root of 1 squared plus 1 squared, or square root of 2. And then tangent of theta would be 1 over 1, which is 1. And we just said that tangent of theta, or tangent of 1 would be in, again, 2 quadrants, which are where? Pi over 4 and 5 pi over 4. But based on where we graph this, we know which one we're going to pick. Pi over 4. Good. So then I get √2 times the cosine of pi over 4 plus I times the sine of pi over 4. And then again, remember, if you've got extra time, these are easy to check, right? So if I know pi over 4 is √2 over 2 and √2 over 2, then I can say root 2 times the cosine of pi over 4, which is root 2 over 2, plus I times the sine of pi over 4, which is root 2 over 2. Multiply those in, and root 2 times root 2 is 2. I'd get 2 over 2 or 1, plus I, 2 over 2, or plus I, and then that matches that, okay? But again, only if you've got extra time. Like, don't be checking every single one and then run out of time on the rest of it. The good thing is that's towards the end, okay, in order, but so you can get an idea.
Wait, so on the homework, there was like a question that was like, change like the, like that form back into like the standard one. Will that be on the test?
No, but you could use it to check, so that's where you will see it used. Okay. Yep. Any other questions on the warm-up? Okay, so go through the review. So we're going way back. It's been a couple of weeks. Really, not that long. For law of sines and law of cosines. I have somebody coming for a makeup today. If they don't, they get the 0. So you will get your quizzes back tomorrow, one way or the other. So we start with law of sines. Remember, law of sines is A over the sine of A equals B over the sine of B equals C over the sine of C. And again, those are irreversible. Like, I could put the sines in the top and then the sides in the bottom, okay? And then I can pick any two at the same time, cross multiply, divide. There are two types of triangles that you're going to get with law of sines, and that is angle, side, angle, in which as long as you're not given, as long as you're given those two angles and the included side, there's no need for like to test an ambiguous case. You would find the third angle and then you would solve your triangle from there. So I'm not going to work through an example on that, but there are examples on the review for that. The part that I'm going to go through with you is the ambiguous case. So if you're given two sides in the non-included angle, if you need to draw them out to visualize it, do it. But basically what will happen here is you'll get a repeat of a letter and then the third letter. You won't get one of each letter. That's kind of how you'll know if there's one angle and two sides. And so this is where you want to assume there's a second triangle until you prove yourself wrong, okay? So we're going to walk through that process. So the only angle I'm given is angle B, which is 30 degrees, and then side B is 27. So I'm going to start with that ratio. B over the sine of B would equal, the only other one I have information about is C. So 32 over the sine of C. And then I'm going to cross multiply and divide. So in my calculator, I get sine -1 of that. So 32 times the sine of 30 divided by 27. And then second, sign that answer. Don't round it until you get to this point. So angle C is 36.34 degrees. And because we're assuming there's a second triangle, we're actually going to call that C1. And then I'm going to divide my page here so that I remember to go back for the other one. So this would be a C2. And I would find it by doing 180 minus the one we just found. So 180 minus 36.34 is 143.66. That's angle C2 is what we're going to call that. I'm going to continue to work on my first triangle, and then I'll go back to that second triangle. So once I've got two sides and two angles, I can find the third angle, which would be A, by subtracting the other two angles from it. So 180 minus 30 minus 36.34. And I get angle A1 is 113.66. Everybody with me so far? Now I've got to find my last missing piece, which is my side A. So I'm still going to use B that was given to me because I know for sure that's right. So I've got 27 over the sine of 30 equals A1 over the sine of 113. Again, cross multiply and divide. And I get A1 is 49.46. I'm rounding these to 2 decimal places, but just pay attention on your test. It will tell you what to do. So now I've got all 3 missing pieces from triangle 1. I've got angle C1. I've got angle A1, and I've got side A1. Good so far? Yes? Okay. Now I'm going to go and I'm going to work on triangle 2. So I already found angle C2. The next step is angle A2, right? So I go to A2 would be 180 minus my initial angle, which is 30 degrees. That carries over to both. Minus 143.66. If what you get from that is negative, so if you can add those in your head and say it's bigger than 180, okay, then you know there's no second triangle. But if it is like this one, where it's an angle, it's small, but that's still an angle, then I know there's a second triangle, and I've got to continue to solve for it. There's only one more thing I need to solve for, but I do need to keep going. I'm going to still use the same information I was given because this carries over to both. So 27 over the sine of 30 equals, the last thing I have to find for triangle 2 is side A. And then I'm going to cross multiply and divide. 27 sine 6.34 divided by sine of 30. And I get A2 equals 5.96. So this one had 2 triangles. When you write your answer for something like this, you would provide all the 1s and all the 2s. Okay, whatever's missing. So C1, angle A1, side A1, and then angle C2, angle A2, and side A2.
Why don't you find C2 with the side?
Because whatever's given to you initially, these 3 things carry for both. So the only thing that's going to have 2 versions is what you're missing. Remember the other option, well, 2 other options. One is there's no triangle, and you'll know that from the very beginning when you go to solve for that first angle, you'll get something that's bigger than 1, and when you go to do the cosine -1 of it, you'll get an error, okay? Or there's 1 triangle where you've worked through the whole first side, and then when you go to find the second angle on the second triangle, it's negative. Then you'd know that there's only 1 triangle. And again, this only happens with 2 sides and the non-included angle. So some of you wasted time on your quiz doing it when you had side angle. Don't waste that time, okay? If it's not 2 sides and the non-included angle, you don't even have to test for it. Questions? Little things like make sure your angles all add up to 180, because some of you could have caught mistakes like that. Make sure the bigger sides opposite the biggest angle, smallest opposite the smallest angle, that kind of stuff. All right, also in that section was the area when you're given side angle side. So if you're given 2 sides in the included angle, you'll have 1 of each letter. Okay, then you can find the area by doing 1/2 the product of the sides times the sine, not the cosine, the sine of the angle. So those letters are interchangeable. If I did 1/2 BC, then it'd be sine of A. If I did 1/2 AC, then it'd be sine of B. You get 1 of each letter. So super easy, just plug it in, right? 1/2 8 times 7 times the sine of 52. And then type it in the calculator. God bless you. I get 22.06, and it would be whatever the units is squared. Make sure that you can deal with degree, minute, second notation. Make sure you know how to get out of it, like that menu, the second apps menu. either when you're typing it in, like if it was part of this, make sure you know how to plug that in. And then if it's law of sines or law of cosines and the answer needs to be in it, make sure you get that angle in it. So if I give it to you in degree minute second notation, your answer for the angles need to be degree minute second notation. And that's that little arrow DMS button. That's like the fourth thing down on the apps menu, the angle menu. So again, you wouldn't put area in that format, but you would put an angle in that format. Questions on that one? All right, then we got to law of cosines. So law of cosines, all those formulas are there. Okay, you need to make sure you know those. There's a Quizlet actually that combines law of sines, law of cosines, and the vector stuff all together. It's on the very bottom of the module where the review is. Take advantage of it. Use it as much as you need to make sure you know this stuff. So law of cosines is used with either side, angle, side, or side, side, side. If it's side, 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 and you switch from law of cosines to law of sines, make sure you go biggest angle first. If you're not switching, you avoid this. But if you do switch between the two, you got to make sure you start biggest angle first. So if I was looking at this one that's here, I would start with C, right? Because C is the biggest side, which means it's opposite the biggest angle. So I'd get the cosine of C equals A squared plus B squared minus C squared over 2AB, which is 12 squared plus 17 squared minus 20 squared over 2 times 12 times 17. And this is where you got to be really careful when you type it into your calculator. I'm going to do inverse cosine, but you need to make sure, because it automatically opens one set of parentheses, you've got to group together your numerator and your denominator so that they know that they're separate and what order to do it in. So second cosine, open the parentheses again, 12 squared plus 17 squared minus 20 squared, close those parentheses, divided by, open them back up again, 2 times 12 times 17, and I get angle C is 85.36 degrees. If you pick the largest angle first, then you can switch at this point to law of sines. Just keep in mind you're using now a rounded amount that you found. So if it's wrong, you're going to continue to get it wrong. Safest bet is stick to law of cosines. So if I go to find, let's just say I work my way down to the next smallest one, it'd be B. Then I get the cosine of B would be A squared, which is 12 squared, plus C squared, which is 20, minus B, which is 17, over 2 times 12 times 20. And again, I would do cosine -1 of that entire thing, making sure I open my parentheses for the numerator and then close them, divided by, open them back up again. Then I get B. Then for A, all I have to do is just subtract it from 180. You could also take the time to do law of cosines if you've got the time for A and double check. So I'm going to do 180 minus 85.36 minus 57.91. $36.76. I wonder if you can hear on the video the Jeopardy through the wall. So that's side, 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 okay? The other thing you're going to use for law of cosines is side, angle, side. So if you're given two sides and the included angle, then you're going to use that information to find the third side, and then you're going to carry through using the other ones. Again, if you switch back and forth between the methods, then you can actually introduce an ambiguous case with even side, angle, side if the angle that you're initially given is acute. So if the angle you're initially given is obtuse, no problem. Start with law of cosines, switch because you just solved for the biggest one, right? But if the one you get, like angle A, is 32 degrees, stick to law of cosines. Does that make sense? Safe bet is stick to law of cosines. But if you're going to switch and the angle that they give you is obtuse, no problem. if the given that angle that they give you is acute, then you could be introducing an ambiguous case that doesn't actually exist. Okay? So in that case, I would stick to law of cosines. It's just safer. Questions?
For side angle side,
Mm-hmm.
it's like, do you still find like those largest or whatever first? Like, how about?
So you're only be able to find the last side first. And then, yes, if you stick, so that's why if it's obtuse, it eliminates that problem. If it's obtuse, then you already have the largest angle, and you can go in any order. But if it's not obtuse, if it's acute, then you'd have to go largest if you're switching back to law of sines. But if you stick to law of cosines the whole time, it doesn't matter. All right, and then in that section was also the Heron's formula for area. So when you get given all three side lengths, then S is A plus B plus C divided by 2. And we're not going to round it. So some people lost points on the quiz because they rounded it. Or they divided by 3. Or didn't divide at all. So just be careful there. Okay, you're dividing by 2. And then the area should be the square root of S times S minus A times S minus B times S minus C. And let your calculator do that work. Just give me as much work as you can there, because if you get it wrong, I can't give you partial credit if you've got no work to show.
Can you give us back the quizzes?
Yeah, tomorrow. Yep. And then you're going to go through a word problem. It will either be a law of sines or a law of cosines word problem. You're going to get 2 on your test, 1 at this point, and then 1 later when we talked about force and velocity and that kind of stuff. Just be prepared. Set it up. Figure out based on what your information is, obviously, which you're going to use. Remember, if you want to go back through your quiz problems and your homework problems, all that stuff, there are some on your test review, but there's plenty to look at. That you want to review bearings. You want to review parallel lines. Properties of parallelograms. Remember, opposite angles are congruent, opposite sides are congruent, consecutive angles are supplementary, diagonals bisect each other. Okay. I would say all that stuff is fair game. Then we got into vectors, right? So all of that stuff was what was covered on your quiz. And then came the vectors. So we started with component form and magnitude. How do we feel about that? Do I need to work out that example now, or you want me to go back and do it? We're good? Yes? Okay, I'll do it in the video later, but I want to make sure that we get to some of the other stuff. How about adding and subtracting vectors? Scalar, what's the difference between a scalar and a vector? Scalar is a single number. Vector is going to be in component form. If the question is given to you in IJ format, your answer needs to be in IJ format. So if this said 2i minus 3j and 1, well, it wouldn't be 1. It would be I plus 4j. Then my answer should be in that format as well, if it's a vector. Okay, so we're going to go back to work out the component form and magnitude of this first example. Component form, remember you're taking the first number in the terminal and subtracting from it the first number in the initial. So negative 7 minus 2 is negative 9. And then second minus second. So 6 minus a negative 5 becomes 6 plus 5, or 11. And then you want to find the magnitude. So this is the square root of a squared plus b squared. Or if you want to start from your initial points, the distance formula. But if you have the component form, obviously you're saving some steps. So negative 9 squared plus 11 squared. Underneath your root would be 81 plus 121, or 202. And then you want to make sure that that doesn't break down at all. So this would be 2 in 101, and 101 doesn't break down at all. So you would keep it as the square root of 202, which is another question that will be asked to be kept exact instead of rounded. Then we get into the adding, subtracting, and multiplying by a scalar with a vector. So one thing we just talked about was that the vector would be in component form. That's how you'd know the difference between that. And a scalar would be a single number. So if u is 2, -3, and v is 1, 4, then u plus v would be first plus first, which is 3, and second plus second, which is 1. If it was given to you in this format, then that answer would be kept as 3i plus j. So just pay attention, whatever format it's originally given to you in is how you want the result to be. 4v minus u, you're going to first multiply 4 times v, and you'd get 4, 16. Subtract from it u, and that negative is going to go to both terms. So 4 minus 2 is 2, and 16 minus a -3 becomes 16 plus 3, or 19. And again, if it was kept in if it was given in ij, that answer would be in ij format. All right, then there was finding the component form of a vector with a magnitude given and the angle it's formed with the x-axis. Okay, so if you wanted to visualize it, if it was made with a 30-degree angle, it'd be small over here. And we're saying that the magnitude is 7. That's the length it's traveled. So there's actually two ways to look at this. One was when we talked about word problems and velocity. Like if you were given the velocity, that's the hypotenuse, right? How fast it travels. And it asks you for the horizontal component and the vertical component. With those, I would say use SOHCAHTOA, right? You have opposite and a hypotenuse and then adjacent and hypotenuse. And you know this angle, okay? Those are probably going to be not a unit circle angle. You're going to round those because the word problems would usually do that. Something like this, where it just says find the component form of the vector with the magnitude that forms an angle, you would do the magnitude times the cosine of the angle plus, or not plus because you're component form, comma, the magnitude times the sine of the angle. And then that angle would be unit circle based. You'd plug in the value, you'd simplify. So in this case, it'd be 7 cosine 30 degrees, comma, 7 sine 30 degrees. And then we know on the unit circle, my 30 degrees is root 3 over 2 and 1/2. So this would be 7 times root 3 over 2, 7 times 1/2. And these answers are going to be kept exact, which would look like that. So if you don't remember that little formula, hopefully it's not too complicated, but if you don't remember it, you could always use your triangles. Just keep in mind that you're going to be keeping them exact, so you don't want to use your calculator to find them. And you want it to be, and you would, well, no, it wouldn't matter. This is in degrees. If it was in radians, you'd want to be in radians. If it was degrees, you'd want to be in degrees. Okay, then came finding the component form of a unit vector in the same direction. So we had two types of problems where it asked for a vector in the same direction. One in which it said unit vector, and one in which it gave you a magnitude. If it says unit, unit means 1 unit. So unit means the magnitude of my answer is going to be 1, okay? If it says something other than that, so this one says a magnitude of 5, then we're first going to find the unit 1 and then just multiply by the magnitude at the end. So in the same direction means it would be the vector, well, this would be v. So v over the magnitude. So I would take 1, 4, and I would put it over this square root of 1 squared plus 4 squared. 1 plus 16, which is the square root of 17. So then I'd get 1 over root 17 and 4 over root 17. And then you'll rationalize. So root 17 over 17, 4 root 17 over 17. That's the unit vector in the same direction. And with extra time, you could check the magnitude of that should give you 1. If the question says, find the component form of a vector, notice the word unit is not there. In the same direction as 1, 4, but has a magnitude of 5, then what I'm going to do is what we just did, but then multiply by 5 at the end. So 5 times root 17 over 17, and 4 root 17 over 17. And I'd get 5 root 17 over 17, and 20 root 17 over 17. So again, a vector in the same direction is my actual component form over my magnitude. Split it, simplify it. And then if it says unit, that's it, I'm done. If it doesn't say unit, it will give you another magnitude. You take that magnitude and multiply it in at the end. We also graphed in this section, okay? So remember, if you're graphing the sum, then you're going to take the terminal point, draw a parallel line to the other side, terminal point parallel to the other side. We're making a parallelogram, and where they meet is the terminal point of the sum. For this one, it says find u plus 4v. So the first thing you do is quadruple the length of v, right? So if v is here, I'm going to say that's 1, that's 2, that's 3, that would be 4v. And then I'm going to extend out in either direction, parallel to the other side. And where they meet is my terminal point on the sum. You won't have your ID, so I'll give you a ruler. It doesn't have to be exact, but God bless you. But if you want the ruler for the straight edge, okay, I'll give it to you. And like I said before, there were word problems here in this section that dealt with the velocity, that dealt with a little bit of bearings, okay? Something about the distance it was traveled, finding the horizontal component or the vertical component, that kind of stuff. There's word problems. So that's 6.3 part 2, notes and homework. Okay, then came dot product, angle between, and orthogonal. This was 6-4. Dot product, you're doing first times first, plus second times second. Are we good on dot product? Yeah, so this would be 2 times 1, 2, plus negative 3 times 4, negative 12. Negative 10 would be the dot product of u and v. Angle between, another formula, cosine of theta, would be the dot product of the two vectors over the component forms of each being multiplied together. So I already know the dot product here, which is negative 10. But then I'd have to find the magnitude of u, square root of 4 plus 9, which is square root 13. And then the magnitude of v, which is the square root of 1 plus 16, square root 17. And then I'll actually type that into the calculator all at once. This time, make sure you group your denominator. So you can either put the parentheses around them, or you can let the calculator group them with the square root. That's fine. Just make sure they're not separated out. And then take the time to graph them and see if that looks right. If I graph these two, it should appear to be obtuse, okay, like midway between that 90 degree and the 180 degree. You probably are not going to get all three of these based on the same points, because obviously if I'm finding an angle between, then you know that it's not going to be parallel. So you're going to have that option. You have a separate set of points. If it's orthogonal, then it means my dot product is 0. Or the lines are perpendicular. If it's parallel, then the slopes are the same. So u2 over u1 would equal v2 over v1. With this example, that'd be negative 3 over 2 and 4 over 1. Obviously not. So these would be neither. Dot product is negative 10, not 0, and the parallels are, the lines are not parallel. All right, then the last section is 6.5, which was trig form of complex numbers, just like the one we started with at the beginning when we did our warm-up. So to plotting of them, first thing is obviously you need a coordinate grid, which will be provided for you. And then for -5, I would be 4 and -5. I'm going to go to the right 4, down 5, and that's a single point. And then the absolute value would be the square root of a squared plus b squared, or 4 squared plus -5 squared, 16 plus 25, which is the square root of 41. Doesn't break down at all, so you'll keep your answer exact like that. And then trig form of the complex number. Again, you've got to find the radius, which is the square root of a squared plus b squared. And then the tangent of theta would be b over a. You'll do the inverse tangent to find the angle. But you also want to plot it to get an idea of where it is. So because root 3 is actually approximation, all I'm really worried about is that this is a positive and a positive. So I know the positive and positive ends up in the first quadrant. Now the radius would be the square root of 3 root 3 squared plus 3 squared. 3 squared is 9 times the square root of 3 squared, which is 3. That's 27. Plus 3 squared, which is 9. And I get the square root of 36, which is 6. Then the tangent of theta is b, which is just the 3, over a, which is 3 root 3. And this becomes 1 over root 3, or root 3 over 3. And then again, if you think back onto your unit circle, my root 3 over 3s are at my over 6s. And because I want it to be in that first quadrant and it's positive, I'm going to pick pi over 6. Technically, just the positive tangent would lie in both the first quadrant and the third, which means pi over 6 and 7 pi over 6. But because it's initially plotted in that first quadrant, I know to select pi over 6. And now my trig form is r times the cosine of theta plus I times the sine of theta. So I'd get r, which is 6, times the cosine of theta, which is pi over 6, plus I times the sine of theta, which is pi over 6. And that's the answer. And then again, remember, with extra time, that's easy to check by plugging in the value for the cosine of 6 and the sine of 6, pi over 6, and then distributing the 6 in. And you should result back in the question that was given. Okay, that wraps up your review.